In today's lesson, we're going to be looking at working with samples. And in statistics, we do a lot of sampling so that we can come up with some conclusions on some data. And first of all, we have to look at the difference between taking a sample and what a census is. And if we poll and get information from the entire population, that's called a census. In the United States, we do that every 10 years, and we have forms that are sent out to every household, and we answer the census questions and gives our government information about the size of our family and helps that census helps divide all the federal funding up to see where libraries need to be built, depending on how dense the population is and so on in an area. But in any case, census would be if we have the entire population being considered. Now, that is not realistic for us in the United States. That's over 300 million people that we'd have to get information from if we want to find information, say, about fast food service. What's their favorite fast food service? And we're not going to use a census for that type of information. We're going to use samples, or we're just going to take a part of the sample, a part of the population, excuse me. Now, sometimes when we sample, we get means where we might ask somebody some question about what is the normal speed that you drive on the way to work, or how much time does it take you to drive on the way to work. And so we get a number answer. But quite often we will also ask people whether they vote yes or no on an issue, or whether they have a particular characteristic or not, like attached earlobes, or can you curl your tongue, etc. So, or would you vote for a particular candidate? And it's a yes no answer. And so if we're dealing with sample proportions would be we know we polled a certain number of people, n, and we would want to find out how many of the people in that sample of n had or agreed with some particular characteristic, and we would just write it as a proportion. Now, that proportion, by the way, we usually call a sample proportion a p with a little caret at on the top, which we call p hat. So kind of a funny characteristic to call it, but that's what it is. Now, when we sample, one of the best ways to sample is take a random sample or a simple random sample. And a random sample is not where we go to a place and pick people who are our friends. A random sample, if we did a random sample within the high school, we would go down to one of the people in the counseling center or in the office and ask for a list of all the people in the school. We would number all those people on that list, and then we would randomly pick numbers from that list until we had the sample size that we wanted. So random is not convenient. We'll have that term up in a second. But every member of the population would have an equal chance of being chosen if we have a random sample. Now, quite often when we do studies around here and sample around here, people will use convenience samples, and we do have to be careful about using convenience samples because we can assume that they're going to be representative of a population when, in fact, they quite often are not representative of a population. So a convenience sample is where we're sampling members who are easy to find. And as I said, bias is usually present in that type of sampling. If you go to your seminar and you poll people about some particular issue, because those people are all in your seminar, there are a number of reasons why that sample may be biased. Now, when we talk about sampling, we know that let's say that this is some population here, and the population has capital N people in it, and there's a particular proportion. Let's say it's a population that's going to vote for a candidate, and there are capital N people in that community, and there is a true proportion, we'll call that little p, that will vote for that candidate, and that will happen on election day. Now, we sample and we do simple random samples, and we would get a sample of size n. It's going to be small relative to that capital N. And then we would count how many people said yes out of little n, and that would cause us to get something called a sample proportion, which we would call a p hat. Now, we know that if we throw those names back into the pool of people and we take a second random sample of size n. And again, count how many people said yes out of that, and we get a p hat, another sample proportion. There's my first one, there's my second one. These two numbers are bound to be different. And so we know that when we sample, we're not going to always get the same result. And we would love for these two p hats to be exactly the same as this little p, which is the true proportion if we had done a census. However, we know that these are not going to always be the same by any means, and they're going to vary. And that's what I mean by talking about a margin of error. When a random sample of size n is taken from a large population, so this capital N is large, the sample has a margin of error with 95% confidence of approximately, if we take 1 divided by the square root of that sample size that we took and add that and subtract that away from this proportion that we got, we'll find what we'll call a confidence interval. And so we're going to get an interval estimate for where we think this little p, that's the true proportion, lies. And once we see it in an example, so we'll get the little formula down first of all. And again, this is just an approximate formula. In AP statistics, you learn something much more technical than this. But that's an approximation right now of what the margin of error is. And then we produce confidence intervals. And in that, a confidence interval is an interval of values in which you believe a true population proportion will lie. So we're going to get an interval of numbers that will say, we're pretty sure that this true proportion lies between blank and blank. So let's look at an example and you'll see what I mean. So we have a random sample of 500 teenagers, so we know that that's our little n. 328 had never attended a popular music concert. And so we want to first of all write the sample proportion for those who have never attended a popular music concert. And then, instead of writing it as a proportion, we'll write it as a percent. So as I said, it is called a p hat when we sample. The true parameter, or the true proportion that would be from a census, is little p. P hats are samples. And we had 328 out of 500. That comes out as a decimal of 0.656, or approximately 65.6%. Now we're going to calculate the margin of error. We're going to go back and use this formula. And you can see that for us, the approximation for the margin of error, we only need the sample size. And so we calculate that. I'll try to get that straight. There we go. And so plus or minus 1 divided by the square root of the sample size. And that gives me this decimal. Now this decimal would go with that proportion. This margin of error percent would go with this percentage that we got for this sample. And now we're going to create the confidence interval. So we take what we got, the p hat, plus or minus what we got for the margin of error. And I'm just shortcutting that as ME. And so our sample gave us 0.656, but we know that, again, if you keep sampling over and over, this is not going to always stay the same. So we don't think that this is actually what the true proportion is. We just know it's a sample, which will vary. Add on and subtract away our margin of error that we just calculated. And so we are 95% sure, or 95% confident, that the true proportion of teenagers who have never attended a popular music concert would be somewhere in this range. If we want that confidence interval proposed as a percentage, then we would need to come down here and use this percent plus or minus the margin of error in terms of a percent. Okay, let's look at one more example of that. Okay, next one. We have a random sample of 200 high school seniors found that 60% already had career plans after high school. So they knew what the career was, at least they think they know what their career was. And we're going to find the margin of error of the sample. So we know that we have to first of all find what is the estimate for the proportion of those seniors who have already planned a career. And then we know we need to find or add on our margin of error. Well, We actually don't have to do this little calculation this time because they've done it for us. A random sample of 200 people, they already did the quotient. They already divided the total number of successes. So we would have had 120 people would have said, yes, I have a career already planned out of 200, and they've already done the calculation for us. Now, if we wanted to do this as a decimal, we could. We could leave it as 0.6 as opposed to 60%. Then we need to add on and subtract away our margin of error. Now, when we calculate the margin of error, you will be getting the decimal number. If you want it to a percent, remember you have to move the decimal place 2 places to the right. So if I were going to give it as a decimal, I would be ready right here with the 0.6 plus or minus 0.071, and then I can add on and subtract away this, and I would have gotten 0.529 to adding it on 0.671. And that would be the proportion of people, or the 95% confidence level that the proportion of people who are seniors who had already picked a career is somewhere in this interval. If we want it in terms of percents, either move these decimals or originally change your margin of error into a percent and add and subtract it away. Now we can see we can make this interval, it's pretty wide. Right now it's pretty wide. It's almost 15 units wide. And if I want to make this interval less wide or not as wide, I have to sample more people in order to get that margin of error to get smaller. So that's the only way to reduce that margin of error is to sample more people. And then I can get a more precise estimate of what my interval is. I can make it a smaller width. Now, the remainder of the section is going to talk about some problems that we can have with sampling, because a lot of people do sample, and if we have my AP Stats class or other people and maybe in AP Gov are taking some polls, they have to be very, very careful about the way they poll, because you can get a lot of, for no better terms, junk data by sampling improperly. So let's look at this one and you'll see what I mean. The School Council Dance Committee is trying to decide whether to have a band or a DJ for the fall dance. They decided that each of the four committee members should survey the students in their pride classes or in their seminar and identify any type of bias in this selection scheme or this sampling technique. So each person is going to go to the seminar and ask their seminar people what they think. And at first you could look at that and think, well, I think that would be a good way to do it. Well, it depends on whether you want to be careful about bias or not. They are using what we call a convenience sample. And any time we use a convenience sample, we have a possibility of having biased results. The way someone words a question, if you're the person's friend who is coming into the seminar and they might say, which do you want, and you kind of know which way they already feel about this particular issue, then if you're the person's friend, you may just agree. Or on the other hand, maybe you like to be argumentative, so you would go against the person. We also have the seminars, maybe the seminar is only the math lab people. So all the people happen to be people who are a little more successful in math. And maybe people who are successful in math will have a different opinion than what the normal population is. So we have to be very careful about the way we sample when it's a convenient sample. Now, the following lists are basically different problems that we can have when we sample, when we conduct surveys. And so one way is just the wording of the question. Sometimes you can have a question worded in such a way that maybe they might say, how do you feel about giving aid to the poor? And someone might say, well, I would agree with doing that. We need to give aid to the poor. On the other hand, someone might say, how do you feel about our welfare system? And the word welfare has a negative connection to it, and you may, just using the wording a little differently, you may taint the answer. Interviewer bias. The interviewer may cause a biased response. If you're being asked by one particular person the question, you may feel a little apprehensive about giving an answer because that particular person is asking you the question. So if they do one-on-one surveys, they usually will establish kind of a rapport or a relationship with you so that you would feel comfortable in answering questions, and the interviewer is supposed to try to remain as neutral as possible and not react to any of your answers. Now, response bias when a response bias would be when somebody responds and they respond untruthfully. So if someone were asking about someone's smoking habit, alcohol habit, um, uh, promiscuous activity, uh, somebody may lie because they don't want other people to know their responses, or they may exaggerate or underestimate something because they don't want to give answers out and they're apprehensive about that. So that's an issue. Another is undercoverage. Sometimes people are left out. Anytime you're looking at a census data, people who don't have homes, people who are out of the country, those people are not going to be represented because they will not be taking part in the survey. So we have issues of undercoverage. Long ago, when phones first came out, they did some polling back in the 1920s, and they thought that one political candidate was going to win because they used phone numbers to do pollings, and it ended up that their polling results were totally off. The opposite candidate won, and it was because of they undercovered all the people who did not have home phones at that time back in the 1920s. So undercoverage is a big issue. Now, another issue is voluntary response. If you allow people to self-select themselves and say, I need some people to answer a survey, and those people volunteer to respond, quite often voluntary response questions will be, again, biased. And we talk about, I could read you something from Ann Landers in Dear Abby, but again, I'll leave that for classroom time. And lastly, non-response. A lot of people, if we send out surveys, they will choose not to be part of the survey, and you can't contact them. Might be on the phone that they're trying to get hold of people, and they keep calling and they can't get through to them. So people, either by having something mailed to them and sent to them, don't respond, or they choose to not answer a phone and not participate, hang up. And so if they had been selected as part of that random survey and they won't participate, it can give you some bias in your data. Now, one other little last thing is we do have to be careful. I just wanted to bring up these terms that if we are trying to find out if there is conclusive evidence, let's say that one particular, let's say a pill, let's say we're trying to find out if we have some information as to whether a certain type of medication works well for people with ADD. If we really want to see whether the medication works, we would want to perform an experiment, and that would be deliberately imposing some treatment on individuals to observe their response. And in that type of issue, we would randomly put people into two groups. One group would end up getting what we would call a placebo, basically a sugar pill, and the other would get the ADD medication, but you would not know which one of these you got, nor would the doctor know which one you got. And then they would look at your symptoms to see if, after the fact, if this actually did cause behavior to be different. And again, we would want people randomly put into these groups. We would not let them self-select. It would not be voluntarily going into a group. And then that is a basic setup of an experiment. As opposed to observational studies would be if we observe individuals after the fact, basically. So we observe individuals and measure variables, but we didn't attempt to influence the responses. And an observational study would be we would look at people who have taken this particular drug, and we would look at their behavior and see how it's changed, but we haven't divided them up into separate groups. So I usually think of observational studies as you decide to look at the people after the behavior has already taken place, and then try to see whether one type of medication maybe had some type of an impact. But experiments are always the best way in order to find out whether something is a valid valid medication, a valid treatment for some type of an issue. So simple formulas, you didn't have much to do as far as your formulas dealing with finding your proportion plus or minus a margin of error, and then we have a lot of other terms that are involved in statistics as well. All right, time to get to work.